Okay, there is another question. A diffraction grating is used to determine the wavelength of light. To determine the diffraction of light, describe the diffraction of light at diffraction grating. These are normal questions. Diffraction always take place at slits, apertures, or corners. Diffractions means a wave passing through slits. Your light, if he is just concerned about the light wave passing through slit, spread around as geometrical shadows. Or the spread around, that's fine. By reference to the interference explains zero order maxima is always where the path difference is equal to 0, and first order maxima where the path difference is 360 degree or 2 pi radians. Okay, that makes minima. That's if by reference to the light, that will be more brighter region, or minima, yeah, that will be a darker region. Those up to first 2 points, they have no issue. Actually, the issue lies, or some confusion lies, when you start attempting the part B and some of its parts. Now there is a graph of sine theta and lambda in nanometers. So in graphs, you first get your mind ready for some kind skills related to the graph, like area under the graph or the gradient. But here I can easily see that the gradient of the graph is sine theta over lambda. And it's a matter of means the topic we are dealing is diffraction grating. So d sine theta is equal to n lambda. So the gradient sine theta over lambda will definitely give us this thing. Means n over d, that is equal to the gradient. Let's see what he says in the question. Can I determine the gradient of the line? So you have gone through the gradient, and if we calculate the gradient, it comes out to be, you use the whole process. I just want to get out of it to save the time. That is y2 minus y1 over x2 minus x1, and it will definitely have a unit of nanometer or something like that. I think he is only concerned with the numerical value, not the unit. Use the gradient determined in 1 to calculate the slit separation d of diffraction grating. Now gradient was equal to n over d. That was the thing. What we have for n? The angle theta for the second order maxima. So we have n is equal to 2. This implies d is 2 over gradient. Alright, that gives us 2.5 10 to the power minus 6. There is a hack. D always come, and most of the time they comes as a 10 power minus 6. Fine. You have to study the notes from where the D comes. Now here is the point which I want to highlight. Sketch a line to show the result that will be obtained for the first order maxima. If you see here in this formula, the order of maximas and the gradient are directly proportional. Now here the gradient was 8 into 10 to the power of 5, what was here, when the order was 2. When we talk about the first order, then the gradient will be half, because they are directly proportional. So you can write it, they are proportional to the number of orders. So half G will be the shape of the graph that the examiner is expecting. What is the easy way to make the half of this line? A new line must carry the half a gradient. If you just count 10, 20, 30, 1, 2, 34 lines, make it half. 10, 11, 12, 13, 14, 15, 16, 17. Here is this point. 10 and 20, 18. So you have to pick the 9. That makes you the x and y, all the things becomes half. So you just now draw these points. So that comes out to be your proposed sketch. You can use your any other method. If you are very good at maths, you can use how to draw the half gradient and it will be done for you. Okay?